Everyone, my name is Sanu and I am student of BSc Chemistry on a second year. Today I will be reading chapter Diazonium salt. So let's start. Diazonium salts. Diazonium compounds or diazonium salts are the group of organic compounds with the general molecular structure Rn2 plus X negative, where R may be an alkyl group or aryl group and X may be halogens, hydrogen sulfate, etc. Aryl diazonium salts have been used as intermediates in organic synthesis. Nomenclature. Arene diazonium compounds are ionic in nature. They are salts. This is well reflected their name as they are collectively known as diazonium salt. The word di refers to the two, as a stands for nitrogen, and the last term onium suggests the ionic nature of the compound. Thus, ionic compound containing N are collectively called as diazonium salts, and they are named by appending the word diazonium to the name of aromatic compound followed by the name of the anion. Benzene diazonium chloride can thus be represented by the following two electronic structure in which the positive charge is shared by both the nitrogen atoms. The relative stability of aromatic diazonium cation may be attributed to the delocalization of the positive charge on nitrogen on the pi system of the ring. Synthesis of diazonium salts. Treatment of primary amines with nitrous acid results in the formation of diazonium salt, a compound of type ArRn N plus X negative, where X negative is an anion like chloride, bromide, sulfate, etc. But since nitrous acid is unstable, as a result, it generates in situ by treatment of sodium nitride with strong acids such as HCl or H2SO4. The process of conversion of primary amine to diazonium salt is known as diazotization. Diazonium salt of aliphatic primary amines are highly unstable even at lower temperature. As a result, as soon as they formed, they decompose, liberating nitrogen to form carbocation. The carbocation may undergo substitution and elimination reaction to give alcohol and ketone respectively. As a result, diazotization of aliphatic primary amine is the one of the little or non-importance, and their reaction are also of no importance. The diazonium salt of primary aromatic amines are also unstable, but they are far more stable in comparison to diazonium salts of aliphatic primary amines, and they do not decompose when the temperature of the reaction mixture is kept below 278 Kelvin. Mechanism. The reactive species in the diazotization is the nitrosonium cation generated by the reaction of nitrous acid with acid. The electrophilic nitrosonium ion cation, they nitrosates the nitrogen of the nucleophile amines after a series of protonic shift followed by loss of water leads to the formation of diazonium salt. From the above mechanism, it can be seen that the reaction is dependent on the nucleophilicity of the amino nitrogen. If the electron withdrawing group is bounded to the aromatic ring, the nucleophilicity of amino nitrogen is reduced, making it difficult for the diazotization reaction to take place. For example, p-nitroaniline is a weaker base in comparison to aniline because of the mesomeric and reductive effect of the nitro group. The diazotization of p-nitroaniline is difficult in comparison to aniline. On the other hand, electron donating groups present at ortho and para position to the amino group increase the nucleophilicity of amino nitrogen, thereby increasing the rate of diazotization process. Physical properties. The diazonium salts are generally colorless crystalline compounds with darkness on the exposure to air. Many diazonium salts of nitrates and perchlorates, when dry, they explode on being heated or being struck. As a result, these salts are not isolated as soon as they are prepared in situ. They are immediately used to the further synthetic preparation. However, double salts made from diazonium and zinc chloride and between diazonium and tetrafluoridates are stable in the room temperature, and they have been used as fast dye salts in the manufacture of naphthenol AS dye stuffs. Chemical reaction. There are a number of synthetically useful reaction of diazonium salt, but a distinction has been made between these reactions on the basis of which the nitrogen atoms of diazonium groups are lost and those in which they are retained in the end product. Thus, the useful reaction of diazonium compounds are basically classified into two main groups: reaction in which the diazo groups have been substituted by other functional group, reaction in which diazo group is retained. So, reaction involving replacement of diazo groups by other functional groups are: first, replacement by H determination reaction; second is replacement by hydroxyl group; third is replacement by halogen; and fourth is replacement by Meerwin annihilation. Next is replacement by arsenic group Bart reaction. Reaction in which nitrogen of diazo group is retained is reduction of aryl diazine. Second is coupling reaction. Then coupling reaction is more important, so we will talk about coupling reaction. So we will talk this in topic of reduction in which nitrogen of diazo group is retained. Reaction of aryl diazine. Aryl diazine are synthesis by reducing diazonium salts with sodium sulfite or stannous chloride followed by acidification with the hydrochloric acid. The hydrochloric derivative crystalline out on cooling, which on treatment with sodium hydroxide liberates the free hydrogen derivative. Coupling reaction. Coupling reaction are those in which diazonium salts are linked or coupled with another molecule. The amine that is to diazotize is referred to as diazonium components of the compound with which is linked is called coupling compounds. The whole reaction is commonly called azocoupling. Diazonium salts being weak electrophile as a consequence of they react with those aromatic systems which are activated by a strong electron donating group. It is for this reason diazonium salt usually undergo coupling reaction with phenols and aromatic amines in alkaline, neutral or mild acidic medium to yield highly colored azo compounds. The type of coupling is often referred to as C coupling. Coupling with phenols. Coupling of diazonium salts with phenol is usually carried out in the pH range 8 to 11, and these pH range of the phenols are usually present as phenoxide ions. Coupling with amines. Tertiary amines react with diazonium salts in a similar manner as phenols, except the coupling reaction is carried out in slightly acidic medium. Coupling of diazonium salts with primary amines rarely takes place at the nitrogen of the diazonium ions in weakly acidic medium, leading to the formation of diamino compound. This type of coupling referred to as N-coupling. When the formation of diazobenzene takes place under acidic condition, then it undergoes rearrangement to para-amino azobenzene. Alternatively, rearrangement can also take place by heating below 50 degrees Celsius diamino azobenzene in aniline with aniline hydrochloride, where the P position is blocked. Then the rearrangement takes place at ortho position like primary amines. Coupling of diazonium salts with secondary amines also take place at the nitrogen of diazonium ions. The diazono compounds, as soon as it is formed, immediately rearrange to azo compound. So this is all about the diazonium salts. Thank you for watching.